In a 1941 short story, Isaac Asimov envisioned a world powered by solar power harvested in space. That science fiction dream came a little closer to reality earlier this year when scientists completed the first transmission of energy from space to Earth. The results could revolutionize carbon-free energy. Recently, we met the scientists behind this achievement in Pasadena, California.
Oh my God.
Gosh, we got it, guys.
Yeah.
This video captures a moment some have compared to Alexander Graham Bell's first telephone call.
There we go, there we go.
A microwave beam of energy sent directly from a satellite in space and received on Earth by scientists from Caltech. Ali Hajimiri co-led the team that did it.
It was a little bit unreal initially, and then it took us a little bit of time for it to sink in.
Solar power currently provides about 3 to 4% of the world's energy needs. But it only works during the day or when there are no clouds. In space, the sun always shines. The challenge has always been how to capture enough of it and get it back to Earth.
Let's try this. Can you turn the power off and then turn it back on? Just like, I'm going to keep it in the same place.
Hajimiri has been developing the technology to do this at his Caltech lab for decades. And while that is the future, at Guru, the company he co-founded, he showed us how beams using currently available energy can power basic household devices right now, using that same technology. So there's like a beam of energy right now.
Yes, exactly. And sending it specifically here, nowhere else.
To this location.
Yeah. It's just like standing in front of a, let's say, a heat lamp.
Yeah.
So that's basically the kind of energy it's sending.
At this station, these lights get their power from a transmitter overhead. The direction of its signal is controlled by a joystick. Whoa, that's hot.
While you're standing right in front of it.
I feel my power growing right now. The same power source works on other devices. There's no battery in this drone.
No.
There's no other power source. It's
No.
being charged from up here.
Yeah, correct.
So what? Oh. So I just messed it up.
You blocked it, yeah?
I blocked the power.
Yeah. So you can see that power is coming
So
from there.
it's not getting. So it's going again. So you're powering a drone. Could you power an airplane?
You could, in principle, in the long run, once you have it in space. Yeah, but you have to have the full size system.
Sorry, I just need to do it one more time.
That's all right.
The largest construction project that's ever been done in space is 357 feet, International Space Station. You're talking about something that's a kilometer.
Right, exactly. So this is a much larger structure. But
how the heck do you do that?
So making it different.
Different is why Hajimiri and his colleague at Caltech, Sergio Pellegrino, have a plan to build a gigantic series of what some have described as flying carpets, which would soak up energy and send it back to Earth.
Oh my God, it's going. That's it. Wow.
The first step in that process took place last January, when the team sent a satellite into space with a prototype of one of these flying carpets, also called modules.
So these modules, we envisage them being tens of meters in size, and we are focusing on an objective of 60 meters. So that square would scale up by a factor of 30.
This is going to be a football field in space.
That will be.
And you're talking about hundreds of football fields.
Hundreds of football fields, but all so lightweight that they will just be doing their dance.
Being lightweight and compact reduces the fuel needed to launch into space, which is crucial if they're going to compete with the cost of other energy sources. This is what we're talking about.
Yeah.
It seems very flimsy.
It's very flimsy, and if you flatten it here, see, it becomes even flimsier. I can fold it.
You think it's going to hold up in space?
Absolutely.
When you're talking about sending this amount of energy, I guess people would ask, is it dangerous?
Right, that's a good question, and we've been looking at it from different perspectives. The good thing is that the wavelengths, the frequencies we are using, are the so-called non-ionizing ones, which basically means that they don't create chemical change. But on top of that, this system has various levels of control and safety, so we keep the power density at maximum much lower than what you get from the sun.
Solar power beamed down from satellites in space has the potential to not only harvest 8 times more energy than land-based solar, but open new avenues of power to people who've never had it before.
It's available anywhere you want. I mean, you can send it on demand. So it makes no differentiation between, a big city or a sub-Saharan African village that has no power infrastructure.
What kind of timetable do you think you're looking at?
I think we are looking for commercially available power from space. We are looking at a decade or two.